Okay, now we will continue next point, and next point is two beams one over another behave independently. See here, two beams are placed, but these beams are not rigid connection. In between these two beams, connection is not rigid connection. म्हणजे इथे काय दिसते आपल्याला स्मॉल गॅप दिसते. If connection is not rigid, at that time both beams behave separately. Both beams behave separately. So we have to calculate moment of resistance separately. This is. In that, one note is there. If there is a rigid connection, they will behave like one piece. Suppose this gap is not present, so this beam is rigid beam. आणि जर rigid beam असेल तर तो काय होणार आहे तुमचा सिंगल beam कन्सिडर होईल. आणि मग त्याचं तुमचं हे काय असेल स्ट्रेस डिस्ट्रीब्युशन डायग्राम कशी येणार आहे जर तुमचा बीम रिजिड असेल तर लाईकवाईज ओनली लाईकवाईज. आणि जर बीम मध्ये गॅप असेल तर ते कनेक्शन काय असणार आहे तुमचं रिजिड नसेल त्यावेळी मात्र हे दोन सेपरेट बीम कन्सिडर केले जाते. सो दिस इज अवर पॉइंट. Then next, example 1. Okay, here one example is given. A square beam laid flat is then rotated in such a way that one of its diagonal becomes horizontal. How is its movement capacity affected? Okay, here two different shapes are given. Okay, one is for square and second is for rhombus. Now we have to find out a ratio between these two. So first we will consider strength for rhombus divided by strength for square, which is equal to section modulus for rhombus divided by section modulus for square. Okay, section modulus for rhombus. So section modulus for rhombus is a cube upon 6 square root of 2. And section modulus for this square is a cube upon 6. Because of section modulus for rectangular section is BD square upon 6. Now here for this square side is A. So we will put here A into A square by 6, which is equal to a cube upon 6. So section modulus for square is a cube upon 6. After solving, we got 1 upon this a cube gets cancelled. And what is remaining? 1 divided by 6 root 2 into 6 divided by 1. So what this one 6 and 6 gets cancelled. So what is remaining? 1 by 2. So 1 by square root 2, which is equal to 1 divided by 1.414. 1 divided by 1.414 is 41.4%. So our option A is correct. म्हणजे इथे काय केलेलं आहे तुम्हाला की स्क्वेअर दिलेला आहे आणि तो रोटेट करायला सांगितलेला आहे. जर तो आपण ऍक्सिसला रोटेट केला तर इथे काय होणार आहे तुमचा रोम्बस जनरेट. मग सेक्शन मॉड्युलस फॉर रोम्बस डिवाइडेड बाय सेक्शन मॉड्युलस ऑफ स्क्वेअर. After getting a ratio, we have to find out percentage, and this percentage is 41.4%. So option A is correct answer. Okay. After that, next here 3 different shapes are given. First is for rectangular, then square, and this is for circular. Okay, this is for circular. In that, you have to consider section modulus as a constant. Okay, section modulus as a constant, and you have to find out moment of resistance. So moment of resistance for this rectangular section ratio is 0.8. Here 1 and here 1.2. So the ratio between this or comparison of this rectangular, square and circular section. So for circular section, a ratio is higher. After that for square, and after that for a rectangular. Okay, so this is little bit concept. After that, next is now we will see questions on this theory portion. So first question, I will read just. A portion of a beam between two sections is said to be in pure bend when there is option A, constant bending moment and shear force, constant shear force and zero bending moment, constant bending moment and zero shear force, none of the above. Which option is correct for pure bending?
Option C.
Option C.
Option C or option B?
C.
C. When we say pure bending, bending moment is constant and shear force is zero. So this is called as pure bending. So option C is correct answer. After that, second, the assumption that transverse section which are plane and normal before bending remain plane and normal after bending results along a cross section. Linear variation of stress, linear variation of strain, constant strain, non-linear variation of strain. Which option is correct? Suppose this is our cross section, this is neutral axis and this is strain diagram. Okay. Here C and here T. So which option is correct? Option B is correct, linear variation of strain. And then third, curvature of a beam is equal. Curvature of beam is equal. So EI upon M, M upon EI, ME upon EI, MI upon E. Which one is correct? So curvature means B, M upon EI. M upon EI is correct answer for this curvature. Okay, now we will move towards next point, next question. Now see here, two beams A and B are simply supported, subjected to identical loads. The two beams have same width. Two beams have same width, but beam A has double the depth of beam B. Okay, beam A has double the depth of beam B. Okay, the ratio of section modulus of beam A and B is beam A and beam B is. So dA, which is equal to depth of beam A, which is equal to 2 times depth of beam B. So section modulus for A divided by section modulus for B, which is equal to section modulus is B d square upon 6. So for A beam, dA square upon 6 divided by B into dA square divided by 4 divided by 6. आपण इथे काय केले आहे तर dA ची व्हॅल्यू पुट केलेली आहे 2b. ओके, or dB which is equal to dA by 2. And after solving, we get answer 4. This 6 gets cancelled, this BB gets cancelled, dA square gets cancelled. So what is remaining? 4. So option C is correct answer. After that, next question, question number 6. A rectangular beam is to be cut from a circular log of wood of diameter D. The ratio of two sides width to depth ratio is given of the rectangle for strongest section in bending should be. So strength of square divided by strength of circular. So square section modulus is a cube upon 6 and here A cube upon 6 square root 2. So A cube get cancelled. A cube get cancelled. 6 gets cancelled. And only square root of 2 is remaining. So option A is correct answer. The next, a beam of square section 200 mm by 200 mm is fixed as a cantilever of span 3 meter. Okay, is fixed as a cantilever of span 3 meter. What UDL can be applied throughout the length of the beam if maximum stress is not to exceed 5 Newton per mm square? So maximum stress M, which is equal to, we have to apply formula M, which is equal to sigma into Z. Okay, so moment for, we have to find out moment if UDL is applied and beam is cantilever beam. Okay, beam is cantilever beam. So moment is WL square upon 2, which is equal to sigma into section modulus is BD square upon 6. BD square upon 6. So here W into L square. W into L square, span is 3 meter here. W into L square, we have to find out values of this W. Okay, here W into 4.5 into 10 raised to 6, which is equal to 5 into 1.3 into 10 raised to 6. First, you have to calculate this value, BD square upon 6. So width and depth given 200 by 200. So 200 into 200 square upon 6, which is equal to how much? 200 into 200 square divided by 6, which is equal to how much? Yes, please calculate and tell me. 200 into 200 square divided by 6. 1.33 into 10 raised to 6, and maximum stress should not be exceed 5. So W, which is equal to 5 into 1.33 into 10 raised to 6 divided by 4.5 into 10 raised to 6. So you got W, which is equal to 1.48 kilonewton per meter. So option B is correct answer. The next question, the ratio of strength of n loose beams placed one over the other to the strength of integral beam, B into NB is. So loose beam, strength of loose beam divided by integral beam. So loose beam section modulus is BD square upon 6, and for integral beam B N square D square, because here ND dimension is given. So N square D square upon 6. This 6 get cancelled. This D square cancel. This B gets cancelled. So 1 upon N square. So option D is correct answer. The next question, a square beam 4 centimeter by 4 centimeter is cut into 4 equal parts. Okay, see here these 4 equal parts. This square beam cut into 4 equal parts. This is part 1, 2, 3 and 4 as shown in figure. The ratio of strength integral beam to that of loose beam. Okay, integral means whole beam and loose beam means these parts. So integral beam is, this dimension is 4 and this is 4. So BD square upon 6. So B is 4 into D is 4 square divided by 6. Now we will consider for this loose beam, that is for this particular portion. So 4 into, okay, 4 into 2 into 2 square divided by 6. So you get 2 answers. So option B is correct answer. The next question. A steel plate is bent into a circular arc of radius 10 meters. Okay, here radius is given 10 meters. If the plate section be 120 wide and 20 thick, okay, 20 thick, then the maximum bending stress is equal to, and here E also given, okay. So E given, R given, Y given, and you have to find out bending maximum bending stress. So you have to apply equation F or sigma, which is sigma divided by Y, which is equal to E upon R. E is given 2 into 10 raised to 5 divided by R. Radius given 10 meters, so you have to convert into mm. So 10 into 10 raised to 3, which is equal to stress you have to calculate divided by Y. Here 20 thickness is given. So depth of neutral axis is half of this 20 So 20 by 2 is 10. And F, which is equal to 2 into 10 raised to 5 into 10 divided by 10 into 10 raised to 3. After calculation, you got stress, maximum bending stress, which is equal to 200 Newton per mm square. So option C is correct answer. The next question. In the above problem, the maximum bending moments due to that stress is equal to. So you have to consider above problem, and for this given data, you have to find out M. So apply here M upon I, which is equal to E upon R equation. So M, which is equal to EI upon R. M, which is equal to E is 2 into 10 raised to 5. I is, so you have to calculate I. Okay, you have to calculate I. 120 width is given and 20 thickness is given. So 120 into 20 cube divided by 12, that is B D cube upon 12 divided by R. Radius of curvature already given, but is in meter. So you have to convert into mm. So 10 into 10 raised to 3. After solving, you got moment, which is equal to 1600 Newton meter. So option B is correct. Okay, then next question. A beam cross section is used in 2 different orientations as shown in the figure below. These 2 figures are given. Bending moments applied to the beam in both cases are same. म्हणजे इथे क्रॉस सेक्शन त्याचे ओरिएंटेशन चेंज होत आहे, पण बेंडिंग मोमेंट जी अप्लाय केलेली आहे ती सेम आहे. The maximum bending stresses induced in cases A and B are related as. Now we will find out. Okay, so M, which is equal to bending moment is same. So sigma into ZA, moment of resistance, which is equal to strength into section modulus. So strength for material A and section modulus for material A, which is equal to strength for material B and section modulus for material B. So FA divided by FB, which is equal to ZB divided by ZA. Now here ZB is BB square. Okay, ZB is BB square into 4 by 6 divided by, according to this figure, here section modulus values are put, and finally you get value 2 by 1, that is FA, which is equal to 2 times FP, that is strength in material A, which is equal to 2 times strength in material B. So Option B is correct answer. Sigma A, which is equal to 2 times sigma B. Then here also similar triangle rule you have to apply and solve this problem. Okay, already we have studied it, how to apply similar triangle rule. And this is last example. A T section is used in inverted position shown in figure or a span of 400 mm. Okay, span is given 400 mm. Due to application of forces shown in figure, here load is applied P, 2P and 3. The longitudinal strain gauge at F 4 mm from top. Okay, due to this loading, longitudinal strain gauge F 4 mm from top registers a compressive strain of 1.5 mu mm by mm. E, which is equal to 200 GPa. I, neutral axis, that is movement of inertia about neutral axis, which is equal to 2176 mm raised to 4. The maximum value of P in Newton. So we have to find out value of this applied load P. Okay. So from the given figure, okay, from the given figure, 1.5 into 10 raised to minus 6 divided by 6, which is equal to epsilon by 10. So first you have to calculate strain. So epsilon, which is equal to 2.5 into 10 raised to minus 6. So F, which is equal to 0.5 Newton per mm square. After that, you have to calculate section modulus. For section modulus is BD square upon 6 and value is 217.6 mm cube. And finally, you have to calculate moment of resistance, which is equal to stress into section modulus. So answer is 0.28 Newton. Okay. Then next question, if the maximum flexural stress in timber joist of the fletched beam as shown in figure 7 Newton per mm square. Okay, maximum stress given. The maximum stress in steel is Newton per mm square. So you have to find out maximum stress in steel. So here fletched beam is given. In that two materials are used. One material is timber and second material is steel. So modulus of elasticity of steel divided by modulus of elasticity of timber, which is equal to 20. This is given. So sigma s upon sigma t, that is stress in steel divided by stress in timber, which is equal to 20, as strain is same. Okay, strain सेम आहे त्याच्यामुळे काय इथे काय झालेलं आहे तुमची डेप्थ ऑफ न्यूट्रल ऍक्सिस सेम आहे त्यामुळे आपण इथे काय घेतलेलं आहे सिग्मा एस अपॉन सिग्मा टी. नाउ सिग्मा एस which is equal to 20 times sigma t. So stress in steel which is equal to 20 times stress in timber. So sigma s which is equal to 20 into 7, which is equal to 140 Newton per mm square. So option B is correct answer. Okay, option B is correct answer. Then last question, a simply supported beam is made up of two wooden planks. Okay, two wooden planks of same width resisting one upon the other without friction and without connection. There is no friction and there is no connection. The upper plank is of half the thickness as compared to lower plank. The upper plank thickness half as compared to lower plank. The assembly is loaded by a uniformly distributed load on the entire span. Uniformly distributed load is applied on the given condition. The ratio of the maximum stress developed between top and bottom plank will be. So we have to find out maximum stress at top and maximum stress at bottom, and finally you have to calculate ratio between them. So one equation, you know that M which is equal to F1 Z1, that is strength in material 1 into section modulus in material 1, which is equal to strength in material 2 into section modulus into material 2. So F1 by F2 which is equal to Z2 upon Z1. Okay. So Z2, same planks are given, BD square into 4 into 6 divided by here Z1 also BD square upon 6. So this BD square get cancelled, this 6 get cancelled, and what is remaining? 4. So ratio is 1:4. So option C is correct answer. Option C is correct answer. Okay. So remaining questions we will see in next lecture. So we will stop here.